Hi everyone, I am Pranav Patil. In this video, I am going to demonstrate how all the major logic gates can be constructed using only the NAND gates. These videos demonstrate a key concept in digital electronics in which a complex systems can be built from a single primitive building block. Modern processors contain billions of transistors, yet they ultimately implement the same fundamental logic operations are demonstrated here. So let's get started. Basically, what is NAND gate? The NAND gate is a combination of AND gate followed by a NOT gate. The NAND gate is also known as a universal gate because any digital circuit can be built using only the NAND gate. In this video, I'm going to build all the logic gates from scratch using the NAND gates. And let's verify their outputs.
Okay.
So let's start with the NAND gate. I have the NAND gate here. I will place the two inputs as the NAND gate consists of two inputs with one output. Yeah. So let's connect with this. Yes. So this is the structure of a NAND gate. So let's verify it. When both the inputs are low, the output will be high. When one input is low and with a one input is high, the output will still be 1. If both the input are high, then the output will be low. So hence the equation for this NAND gate is given as y is equal to a dot b of whole complement. This expression explains the output becomes low only when both inputs are high. For all other input combination, the output remains high. So now let's get into the NOT gate using the NAND gate. Yeah, now we have the NAND gate with one input, also with a one output. For NOT gate, it only consists of one input, also with a one output. So let's connect it. Here, to create a NOT gate using NAND, both the inputs are connected together, in which this configuration behaves exactly like an inverter. Let me show you that.
Okay.
As you can see, when the input is low, the output is high. When the output is high, the input will become low. So this is the NOT gate combination. So the Boolean expression for this NAND gate is given as a dot a of whole complement is equal to a complement. So now let's build AND gate.
Okay.
So for AND gate, using the NAND, it requires two NAND gates. Here, the NAND gate already gives the inverse of the AND operation. To obtain a true AND gate, I simply invert the NAND output using another NAND based inverter. So that's why we require two NAND gates with the two inputs connected to. So this part act as an inverter. So let's verify it. When both the inputs are low, the output is also low. When one of the input is high, the output is low. When both the input are high, the output becomes high. From this, the expression for the AND gate is given as A dot B. So now let's build the OR gate.
Okay.
Okay, so the OR gates require three NAND gates. So now using the De Morgan's theorem, which states as A plus B is equal to A complement dot of B complement with its whole complement. First I created a complement and then I created a B complement using the NAND based NOT gate. So then I feed this output into another NAND gate. So let's verify this. When both the inputs are low, the output is low. When one input is high, then the output is high. When both the input are high, then the output is still high. So the Boolean expression for the OR gate is given as A plus B. So let's build the NOR gate.
Okay.
So here, a NOR gate is a simply an OR gate followed by inversion. After creating the OR gate using NAND, I add another NAND inverter at the output. So let's verify this. When both the input are low, the output is high. When one input is high, then the output is low. When both the input are high, then the output is low. Okay, so let's build the XOR gate. For this XOR gate, we required 4 NAND gates. As it goes like, so let me connect this with the NAND gates. Yeah. The XOR gates output are high only when the inputs are different. If I keep the one input as high and the other input as low, then the output will be high. When both the inputs are high, then the output will always be low. Unlike AND or OR, XOR requires a slightly more complex arrangement of a NAND gate. So the standard NAND only implemented requires 4 NAND gates. So this video, I understood how universal gates works provides a strong foundation for the digital designs. And also this proves that why NAND gate is called as a universal gate and highlights its importance in this digital circuit design. Thank you for watching this video. Bye.